Okay, the session is live now. I will just give you the host credits back. Okay, done. Angela, you're the host now.
Hi everyone, good afternoon. I hope all of you are good, healthy, and safe. I'm Ankita from NASSCOM's Product Council. Today I have with me Saurabh Gupta, author and GM Data Science at Michelin. He will share his knowledge and experience on why MLOPs are relevant, why does it matter to an organization. A very interesting piece to listen to and learn from. The session's flow will be Saurabh will deliver his presentation for about 40 to 45 minutes, followed by the Q&A. You can ask questions anytime during the webinar. Saurabh will cater to them, most of them keeping the time limit in mind at the end. Also, please do not forget to leave your feedback to help me better my future webinars. Welcome, Saurabh, and over to you.
All right. All right. Thanks, Ankita. And welcome everyone to this webinar. As Ankita mentioned, the title of the subject of this session is going to be ML operations. So, and why does it really matter to the organization when we are already in the age of artificial intelligence and developing ML models day in, day out? So, a quick disclaimer before we jump on to the session: this series is for educational purposes, and in a nutshell, for everyone's understanding, the content that I'll be sharing over the next 1 hour is from my experience, from my knowledge, and what I've seen happening in different scenarios, different cases. A little bit about me. So currently, I work as the general manager of data science and analytics with Michelin Digital. My experience for the last 14-15 years has been around the data architecture, data engineering, data science. I'm an author, so I published the first two books of mine on Oracle databases. The last one, which is in 2018, was on big data lake and how basically we build the data lake. What are the key considerations as an architect or as an engineer you have to keep in mind to build such large data systems? I'm an alumnus from Harvard Business School and did my master's in data science and analytics from BITS Pilani. And if you want to connect, if we can chat of this session, feel free to connect with me on LinkedIn or Twitter. Okay, the agenda of this session, MLOps, it's very clear. It's a collaborative practice to operationalize the data science solutions. Okay, but in next 60 minutes, but the intent and objective of the session is going to be to give you the motivation and understanding why ML operations is important. Okay, and it's very often, going by my experience, it's very often that we leave this operations piece apart and we focus majorly on the research and development of AI solutions, but we tend to forget the part which is very, very critical, that how do we operationalize all those cool fancy solutions so that business makes an impact, they feel the impact of artificial intelligence, and plus on top of that, how do we build the value services of managing or monitoring such solutions? And then there is of course, a conflict between who does what. So I'll also talk about the skills that are required to support this productionization, or say, if you will, the operationalization process. And in between, I'll be covering the process flow and what are the key stages to be tapped upon. There's plethora of documentation available over internet, and then there are very packaged offerings around the ML operations available. But I have tried my best to put in this session what is very relevant, and what are the major points where usually we get stuck up. Uh, okay, so before that, to set up the context of this session, I would love to start with a slight primer on AI and machine learning. So the terms are not new. We all, I believe, all of the attendees, all the audience, we all understand. We are very much familiar with these terms. Artificial intelligence is nothing but an intelligence that augments, or say that helps the human intelligence to automate stuff, and we can offload some of the work that we do to some simple programs and machines, and put them on an automated framework, so that next time when we come back, we do not have to start things from scratch. Things are available, outputs are available. So that's what we call the artificial intelligence. Very simple. Machine learning is a field, or is a stream of AI, where we train a machine to learn something. uh, when we say learn, that means we give them the some of the predefined outputs. For example, in a basket of fruits, I need to tell a machine that what is an apple, what's a mango, and based on that, based on the classes, I need to provide sufficient data sets so that it understands, it builds that confidence that, okay, whenever the next time a basket of fruits comes, it will be able to differentiate which one was an apple and which was what is an mango. There's other flavor of machine learning available, which is called unsupervised. So the learning and training part, we again offload back to the machine, saying that you learn the patterns, you learn whatever you want to learn on a given data set, and I will decide next time when we predict whether your predictions were accurate or not, or aligns with my expectations or not. So that's the unsupervised machine learning. Then there is a specialized stream of AI which is coming up, which is not coming up. In fact, it is already in there, but it's one of the most fascinating streams of AI as we speak. It's called deep learning, and within deep learning, the use cases that we see is some of the complicated use cases around vision, where and then there's a reinforcement learning, that based on the outcomes you go back and feed this model again with the outcomes and learn again and come back and refine your outputs, refine your predictions. So it's a much more specialized way of making the machines and programs learn through neurals. And the best way we can correlate the way deep learning works is how human brain works. We learn by experiences. We learn something, we feed back that as an input, and then we learn back again and predict some more outcomes. So that's the deep learning. Now, why this everything is relevant? So I have tried to put a snapshot of a Gartner's 2019 CIU survey, and the question was thrown up to the CIU's community was, which technology area do you expect will be the game changer? And the top two were the artificial intelligence, machine learning, and the data analytics. Now, this gives us an insight where we are progressing. We are slightly moving away from, or say ahead of the usual application development and the projects, and we are trying to build more sophisticated applications using AI, machine learning, and data analytics. The data analysis, which I used to do around 13, 14 years back, has matured and evolved into data analytics. Now, data analysis is a very, very static exercise. That means I have set of CSV sheets on my local desktop, and I can analyze and do some number crunching from there. But then data analytics encompasses the data analysis plus some of the platforms and the data acquisition strategy and data governance. So data analytics entails all these aspects related to the data, starting from generation, the strategy to build the foundational blocks of data defense, and then how can we be offensive with respect to consuming this data uh, for 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 predictive purposes. All right, now a quick primer again on the typical machine learning workflow. It all starts when we define the problem statement. That means if we want to do something, we build hypothesis and we define MVPs. Now, MVPs again is an agile term, but which is not very closely applicable to a data science life cycle. But it is always good to define the stages and few milestones of what outcomes will be relevant for the business and where do we call that, okay, we are approaching a right direction or not. So it starts with the definition of a problem statement. Now, once we define it, we need to start with some exploration and development. So for exploration and development, we look for, or we start discovering the data systems where the data is located. We prepare the data in a way we want as a data scientist. We data preparation, data wrangling, and then we build the models. And we choose the best algorithm that goes with a problem statement and with this data. So just for the simplicity, you can think of our data and we are trying to apply some regression algorithm or a classification algorithm, and then we train these models and start consuming the output. And once we see that, okay, this model and the data and everything has been validated, this is as per our expectation, we plan for the deployment. That is where we start packaging the model, packaging the all the ML artifacts. So now there's a clear evolution from being an ML model to an ML ecosystem. We package all the artifacts together and we plan for the deployment. Once the deployment is done, we move on to the management stage, which is starting phase of ML operations. You serve, how do you serve the model? Depends on like what strategy, where do you want to consume this model, whether it goes back into the relational data sets, or do you want to expose this model as an API or a web endpoint that goes into application. So, and then you monitor the model performance. So model management plus the model monitoring, it becomes after production when you try to activate this model in a real time. And then based on the model performance, you put a mechanism to analyze these ML model insights. And based on the deviations that you see, you plan your retraining of the model, or if something goes bizarre, you also plan to replace the models. So there are multiple steps that are involved in between, but just for the case of simplicity, I've tried to define this 5 steps cycle of a data science workflow. So it starts from definition and it goes on and on. It's an iterative cycle. And then you plan to retrain towards the end or plan to replace the model. However, if you focus on the reality check, if you put a glance on where the word stands, one of the latest article that I've tried to take a snippet and paste it over here is in Jan 2020. And if you see the global numbers around adoption of AI, it's only the 14.6 percentage of firms who have deployed AI capabilities in production. Now, these numbers are different for different analyst agencies. However, if you take an average, this number has never ever been able to cross roughly 18 to 20%. So why we are seeing such shocking numbers? I mean, we are aware about artificial intelligence and ML from long time. In fact, AI started as a practice somewhere around 1950s. I was listening to one of the previous NASSCOM sessions couple of weeks back, and over the time it has matured, it has gained some understanding, it has moved beyond the state of excitement, and people started realizing the fact that we have to adopt or embrace AI in some or the other way to be more intelligent, to gain some competitive advantage. But then why sitting in 2020 we still see 14.6 percentage or roughly 18 percentage of adoption? So it's not that easy that if I understand AI, if I'm a researcher, I will be able to make use of my knowledge, my experience, for all constructive purposes. And here are some of the top reasons why practicing AI and ML is that hard. Now, first of all, there is I'll go in a clockwise fashion, covering all of these factors. The rigid mindset, so resistance to change and adopt. Okay, so it's very difficult to transform the culture. It's very difficult. It's equally tedious to tell that the jobs, or say that tasks that we were getting used to, will now be automated with AI. And we were so much used to using that, doing this, following the same sequence of operations in order to accomplish this task, that it becomes quite tough in our mindsets, that how can a program or set of machines will be able to do this job, because that will require change in practices, that will require change of, or say, provisioning of new tools, or say learning the new skills. So there's of course a factor of rigid mindset that prevents to adopt such practices. Then there is a leadership vision. It's not very old when AI was not the part of the strategies of chief digital officers, and for that matter, chief data officers. It took some time to realize that if we are not focusing on the analytics, or if we are not treating analytics and AI solutioning as a strategic arm of digital transformation, we are losing on a big part. So, leadership vision, their sponsorship, their buy-in to pursue the AI practices is again is a sort of a hamper, sort of a blocker in practicing machine learning and AI stuff. The other thing is even the leadership has to be trained on AI benefits, their practices, and have an understanding of how they can transform the business, how they can monetize the outcomes of AI in a better way that can be plowed back to the digital transformation journey. The third factor, which makes the adoption of ML really hard, is the operations. Now, if you have done all the sweating part, if you have developed AI solutions, how do you move them to production? How do you tell the people sitting across the globe can make use of those AI solutions? And that is where the MLOps comes into picture. There were workaround solutions until 2018 or 2019. In fact, I was asked in my, when I was doing my master's in data science, one of the professors stood up and asked me that this is all good. We are talking all good things in theory and even practicals in the lab environments. If I ask you to push it to production and make this AI solution usable for at least 5,000 folks, what will be your strategy? And I had no answer. I said that, okay, I'll embed it within the data pipelines or something like that to make it operational. But I knew that this is a workaround. This is not a standard solution for industrializing an ML solution in a production ready environment. The fourth and the final factor which I see is the explainability. Many of us are still say we go by the fact that AI does something, but we are not aware that what happens behind the scene. It's a black box. Okay, unless until we have the equation before us, which says that we can implement that equation even on the Excel sheet, or we can do it even on paper. We don't get the confidence that whether AI solution, or say the predictive outcomes of AI is correct or not. And as a matter of fact, the probability of an ML solution always, it floats between 0 to 1. So the higher the probability, or the better the accuracy and precision, we consider the AI solution is good. Otherwise, we say we'll just write off the solution saying that this is not as per the outcomes, or not as per the expectations. So explainability is a big factor. The AI solution, or say the person who is building the AI solution, both of them are stand equally responsible in explaining what's happening, why do we see such outcomes, and should be able to interpret and tell the audience, the leadership, that how it will help us in achieving certain business outcomes. Now, moving ahead, okay, now I'll zoom in on the third factor, which is the ML operations. Now, going by the terms, Is MLOps same as the DevOps? Well, it is. So DevOps is, we all understand, DevOps is the union of people, process, and product. It lays out uh, on strategical stuff. It automates the pipelines that take care of build and deploy process of these software artifacts. And their DevOps in case of machine learning and data science is nothing but the MLOps. So it's an ML engineering track where data scientist and operations team work together to build ML ecosystem in production and activate the monitoring of ML models. However, there is a difference between what we are trying to do under the hood for MLOps versus DevOps. So machine learning model is not a piece of code, while in case of DevOps, all the artifacts is just a piece of code, right? So in MLOps, there are things, there are, I'll be talking about those specific areas which are different from DevOps. The testing piece, how do you test, how do you monitor the models, is not the same as what we will do in DevOps. However, just for the sake of better correlation of terms, I would say MLOps sounds similar to DevOps. Okay. Now, what is ML operations? Now, ML operations is the mix of is the convergence of point for machine learning, the DevOps, and the software engineering. Now, machine learning, if you focus on the roles that are involved here, the machine learning guys who are the data scientists, and they will develop the solution. They have understanding of where the data is coming from. They have discovered the data things already, and then data engineering always helps them to provide the quality data in the right time, in the right format. And then there is a development team which again comprises of the DevOps folks who have skill set of the CI/CD pipelines and planning the automation. And then there's an operations guy who takes these steps, or say rather instructions, to monitor and manage these pipelines for rest of the life, unless until the solution is active. Okay, so now the coming to the scope of MLOps, why we are talking so much about ML operations. Now, one of the research reports that I would refer you to go through, and I've captured some of the top highlights of this report from Cognilytica. It's relatively immature as of now. This is their global assessment, and the market for ML operations is still growing. So far, the operations as such, whether it is for development or for ML, it was very much active within the boundaries of Facebook, LinkedIn, or Google. But now, once we connect the business outcomes and the profitability of A solutions with the development, we say that it's not pretty mature, because the understanding of ML and operations has not flowed out a lot in all the organizations. Then this is the market is still the development centric, but it has the potential to become the consumption oriented. That means practices of MLOps will very soon flow into various arms, various industries. And the expectation is that it is growing at a CAGR rate of at least 10.5 to 11%. And by 2025, or the potential of MLOps, or say the market is expected to grow to $4 billion. Who are the major players who are building reusable components, or say the packaging the components together for ML operations? We have Azure Machine Learning, we have AWS SageMaker, who is providing specialized services around ML ops. And then there are features available within the Data IQ, ML Flow, and Data Robot, who are uh, who have the products for end-to-end machine learning practices, or say industrializations. They do have the specific features around ML operations as well. Okay, so now what are the challenges? Why ML ops is still immature? Now, this should give everyone the motivation that you can resonate well with these also the situations you are in. What are the challenges of operationalizing a machine learning model in a production? Now, before that, I would say the machine learning model to production is not just putting a model to a pipeline. In fact, it is from model to an ecosystem. What we say in ML in production is an ecosystem. It is a combination of data pipelines, all the artifacts, and then deployment of a particular one piece of ML model, and then the experiments with different parameters. And out of all these hyperparameter tuning, you select one model that goes for deployment. And then after that deployment happens, you manage and monitor this particular model. And then under the monitoring, you also do the data drift and model drift monitoring, and based on the insights, and then take a call whether to retrain or replace, or maybe go for an event-based retraining model. So if you can correlate, if you can visualize this, all these steps which I just mentioned, it's an ecosystem which allows ML model to be healthy in a production pipeline. Okay, now coming to the challenges part. Yeah, the first one is the dependency on the training data sets. So the data volume of input data feeds, which this model leverages, may change over the time. And as and when the data volume changes, the model performance has all the way, all the authority to degrade, has all the right to go down, and which will directly impact your predictions, which will directly impact your business outcomes. So there's a huge dependency on the training data set. And whenever we are using an AI solution for production purposes, we have to keep an eye on which data set this model is being trained on, and how much of the volume was considered, what was the distribution between training data sets and the testing data sets, and in the daily runs, how we are using this uh, model. And then the second one is the model health monitoring. Is AI useful? This is the question every time we keep on asking, that whenever how do we say that the AI solution that the applications and the business are using, is it useful? Is it making an impact? And that all depends on how healthy the model is. How do we say that 85% of accuracy is better or is not good, depending on the outcomes it is connected to. And then the complexity of ML pipeline. This is an entire exercise. It involves the data systems, data stewards, and then infrastructure and the platform, plus the automation. So it's you have, in fact, you have couple, different set of pipelines for deploying a machine learning model in production. You have build, release, and then retraining pipeline. How do you build that? Do we have the right set of skill set who can manage and monitor and operationalize these three different pipelines running in parallel? Then you have the model versioning. How do we version this model? How do we do the A to B testing of different models? How can we encourage and enable the art of experimentation? And finally, the model selection. So, uh, so now you can see that how many challenges do we need to tackle in order to operationalize our machine learning model in production. And last but not the least is who does what. There's of course a big question in operationalizing a model. Data scientists, they have the argument that, okay, we are done with the exploration and development. Should we be the part of the industrialization process or not? And at the same time, architecture teams would uh, have a little difficulty in understanding that what are the exact requirements of MLOps, because they come with the DevOps mindset, and it's very difficult to convince them that, or say let them know and explain them that what are the intrigues, what are the intricacies of an ML models are, and how it has to be uh, how it has to be modeled later on, or how it has to be managed. Okay. Okay. So now, why should we adopt MLOps? What are the benefits do we get? So I captured one of the comments from an analyst who says that the large enterprises, they struggle to apply the deep learning and other ML technologies successfully. And this is a big bold statement that she made. And the reason is they have the AI researchers, they have the data scientists, ML engineers, but it's very difficult to embrace ML ops and put ML and AI to use, which is the compound of machine learning development and operations. But the benefits that we get is the reproducibility, okay, the monitoring, management, continuous, and governance. What's reproducibility is the ability of an ML model to get packaged and along with all the related artifacts and support reproducibility. That means it can be reproduced in other environments as well. It also connects to the concept of portability. For example, if I have developed a particular machine learning model once and I want to reuse this model again and again, how can I port it to in different environments? And uh, that's the concept of reproducibility and being able to port on different environments and make use of it and embed it within applications to make use of it. And the way it is done is using the concept of Docker containers and pushing them onto the Azure, sorry, not the Azure, but the Kubernetes services, so that the containers can be auto managed and we can use these containers and push them anywhere we want. The second is the monitoring. How do we track the shifts in data? How we track that for a given data set, for a given volume of data set, how the model is performing, what's the health of that model. It allows us to monitor the data drifts and the model deviations. Management, which is I consider as the core of ML operations. This is why there's a big push behind the MLOps, is the versioning of these models and tracking of these models, how to get one holistic view of how the models are performing, their metrics from a particular perspective, which is on the technical aspects of a machine learning model, like publishing an F1 or a recalls score, versus how it connects to the business metric. If we have defined some threshold, then how the machine learning model is performing against that particular threshold. Then the continuous one that, and this is the pretty simple, where it connects back to the story of DevOps, that how do we ensure the seamless deployment without any manual steps and monitor these production runs. So finally, the governance, the framework for auditing, compliance, and the access control. Now, especially I've put the governance, which you will not find in multiple documentations. The governance is I consider this is equally important. The auditing and compliance and access control, what I'm trying to mention here is, it's not about whether the data input to the machine learning model has the accessibility factor associated or not, but in fact, who works on such pipelines is a big factor. We cannot. It's quite difficult, and this is again by the experience that it's not very easy. That if we have laid down the machine learning operations framework, everyone in the operations would have the similar understanding. So how do you standardize the standard operating procedures on machine learning model, and how do you audit who from the operations desk is working on what set of things, who has the access to such ML models, and who can monitor and make some quick changes whenever something bursts out in a production pipeline. So governance around the ML ecosystem in production is equally important for rest of the factors. And this is why in many of the implementations that we have done, we have incorporated the governance framework we have built on top of the ML pipelines and the ML ecosystems. All right, so now coming to the practical implementation of ML operations. So you start with the preparation of data. You can connect back to the machine learning lifecycle that I shared in the starting of this session. So you start with the data ingestion, data snapshots, and the data preparation. So under the data preparation, you'll find some of the data wrangling exercises. You'll find normalization, transformation, and then in the feature engineering. Uh, and then you start with the model building and training exercise. You do the hyperparameter tuning, and then automatic model selection, then testing of these models and validation. And once these steps are done, you go for the deployment and the model serve strategy, how you're going to distribute and consume this model for your business purposes. So in terms of the tactical works, or say how these steps look in practical scenario, it again, I would say that nowadays the products that are providing the MLOps as an offering, as a feature, they have these APIs, or say they have both the versions. You can either go for an interface version of all these steps, or even they have the APIs, the libraries available. So someone comfortable with writing their his or her own scripts can make use of uh, hyperparameter tuning, the model selection, testing of the data, validation, and doing the deployment. Okay, so once the post the model deployment, once you put this particular model on management and monitoring framework, based on the insights that you capture, based on the metrics, you can choose to retrain the model again in future. Now, the benefits of MLOps in from the organizational standpoint. So, what I just mentioned a couple of slides before was how the MLOps adds value to the state of AI transformation within our organization. Now, from the organization standpoint, how does we as different groups, as different teams, get benefited from MLOps? First of all, we ensure the adoption of AI for the business. We increase the number of models that are put for production purposes, put for production use, and encourage the data scientist and the analytics community to continue with their exploration and the development exercises. Then scale AI from exploration to production. Now, this is one of the observation that we had from my previous organization, that we at least 60 to 70% of the time the data scientist spends time in exploration. Okay, just building the ML models. But if you ask them that how much of these models have been moved to production, it's very difficult to answer. And then there are portions where the partial production has also happened, does happen many times. And so how do we scale AI from exploration stages to the production stages? Then third one is the manage and monitor ML for responsible AI. Now, responsible AI, I've seen this is one of the recent buzzwords around AI, that how AI can be responsible. How can we, reduce the chances of ML poisoning and data poisoning, the ML decay. So all these factors connect back to the point that we have to make AI a very responsible stream for the business, and that will happen only when we prevent this AI from getting injected, and that will happen if we manage the ML solutions in productions, when we monitor whether AI solution that we have built are working constructively, or it, because of the data changes, because of the operational practices, there's a decay in the AI that has happened. So the monitoring and keeping an eye on how the ML solutions are performing in production is again very, very important. Finally, the collaboration between the data science and operations. Now, if you see the world before the MLOps and DevOps came into picture, these two teams were shielded, completely shielded. In fact, they used to be, everyone used to do everything. So you do develop things, you are the owner of a solution, you go and plan for the deployment, and then there'd be a team which is responsible for releasing these solutions. But now what we are saying, that after releasing, there's one more step involved, which is called the activation of such solutions. And that this is where the DevOps got evolved. And and this is where I think the MLOps is also heading towards, that it's not the responsibility of one single team. In fact, we should have the team representations from data scientists as well as from the operational desk to collaborate and achieve ML operations together. Now, coming, there's is one more. I've tried to include one diagram, which gives you a granular look on the overall operationalization process. Okay, so you can see, I'll not go into detail. This is very much standard, but most of the the providers that you see, they follow this particular process. So it's a data processing, then model engineering, This is where, and after this, the code and packaging control happens, the data versioning, and then the performance management, and there's a feedback loop. Okay, so yeah, okay. So most of the terms that I'm trying to find out on the screen, it's I've already covered in the previous session, so I'll not be getting into detail. But if there are any questions on this particular slide, feel free to post them, and I can take up later on towards the end. Now, some of the recommendations. So we are slowly reaching towards the end of this deck, post which we'll start with the Q&A. Now, coming to the recommendations to operationalize data science. Uh, First of all, we need to have the right talent, right skill set to take these challenges. And to be very frank, it's very difficult to find the right skill set. We can have the data scientist. It's one of the prominent skill set and the roles that is upcoming in the industry. And then we can have the operations, but how to marinate these two roles, and how to build that mindset who understands the complexities of data science as well as the DevOps. It's literally little hard to find that skill set. So we need to build a team of data scientists plus the operation, and establish the bridge to collaborate and work together while productionizing the machine learning models. The second is robust infrastructure. We have to focus literally on the platform to run ML pipelines. There are a couple of ways, couple of techniques that I have seen in my experience in my career. Is there are ways to run ML pipelines. As I said, you can always embed and club the ML pipeline in between your usual DevOps pipeline, and you just do the stitching of ML output with the rest of the steps. But you lose where we lose is on the model management, model portability, model monitoring, and not ensuring whether model has to be retrained or not. And that becomes little difficult, or say convinced everyone that we have to, now it's the time to retrain the model, right? So the platform is very important. We need to have the platform to support the ML ecosystem. We need to have the infrastructure to build CI/CD pipelines for specifically for ML, and something that can support multiple pipeline for build, release, and deploy. And in fact, we used to call that as the multiple fork type of process. And each of the forks branches are nothing but one single pipeline that addresses a particular scenario of a machine learning model. The other point that I wanted to cover and highlight is the machine learning model is not always similar in each and every cases. Okay, so when we are building the infrastructure, then the versioning of the artifacts which the ML model consumes is very, very important. If there are 5 data science models, they could be using different libraries, different technical toolkit. So how do we support them in the production environment depends on what platform are we building. Is the platform agnostic to all these changes, all these deviations, or it has the ability to soak in the variety, the variance of ML models, right? So, uh, and as we speak, I'm into a platform track as we speak that addresses these scenarios. We are trying to build up the platform which is standard enough to regulate the changes from ML, from different machine learning models, and it can uh, address the variance of ML modeling in most of the cases, at least. The third is the engage with business to scout for an actionable initiative and convince the benefits of AI techniques. So how do we address, convince the leadership, and how we educate them on the benefits of AI solutioning? So it's very important. We cannot just run the platform, build the platform, and offer it for ML productionization. But in fact, we need to have an actionable initiative. We need to have participate with the business to find right use case, and put it onto the production pipelines and show them the benefits of the business. And collaborate with the data ops and operations group to monitor full ML execution workflow, as I said, MLOps, there are two actors involved. There's a data science and there is a DevOps. And then, but then we also need to, bring in the data operations as well. Data operations are the guys who take care of the data flow starting from the data acquisition to the data consumption. And some major activities involved for in their portfolio is the data reconciliation, data refresh, the quality check, the governance, and connecting back with the power users. So how do we bring them in the equation is part of the DevOps strategy. Then finally, the operations guys who are responsible for day-to-day functioning of these ML pipelines. Are they going to operate based on some documentation, some list of instructions, or do we build the operations group which has the right skill set, who can understand what's going on behind the scene with this ML ecosystem? So the building of the team and build and segregation and the clarity alignment of the responsibilities is very, very clear to support uh, uh, this ML ecosystem. The fifth one, they regularly report the statistics of deployed ML models to revalidate their business value. Okay, so with all good things done, all things, whatever we committed, all things done, that you are going to move ahead from ML models to the ML ecosystems, how do we convince and reprove our claim that this is a good approach to go forward? So we need to regularly report the statistics as part of operations and the analysis that a data drift has happened, or say model metrics has degraded, or it has impacted somehow. But whether that connects back to the business KPIs or not, this is very important. We need to regularly report back these stats and analysis for the ML models to the business. Where do we start is think big. We need to achieve, there's a long journey to go. It cannot start from the day one. You can start small by picking one or say limited set of use cases, but then stay really resilient. And that's the reason I say to stay resilient is very often, given the nature and complexity and the variety of ML models, it's very uh, obvious that there will be stages where we get stuck up. We don't know whether the existing pipelines, which were supposed to be automated, why do they fail? So there's a bit of, and that's the reason I say that we do not have to rely on one single process. In fact, build this as a forked process. So you have one pipeline, one approach for particular use cases, but then there are rest of the pipelines also available who can address such complex scenarios. But we have to be patient. We have to think. We have to tell the sponsors or say the leadership that the resilience is very important. We are not failing, but we are building something new to bring in or say enhance the perimeter of this ML ecosystem. Finally, this is the final slide in my deck, how to attain maturity. So the parameters, the criteria of MLOps maturity is listed on the left. The governance strategy, the platform architecture, teams and skills and processes. And there are three levels that I would recommend, from going from experimental to breakthrough to strategic. When we are at the experimental stage, there are discrete ML efforts. There's work in progress data strategy. Now, data strategy is again a big topic to discuss, but what I mean over here in the experimental level is how strong is our foundation with respect to the data strategy, whether we have taken the different routes, the placement or the order of defense versus offense, whether does that exist at the moment or not, the team's alignment to go in this path, and how strong is the DevOps practice? Are there any experiences that can be used, reused, or leveraged to build MLOps strategy or not? In the breakthrough level, we assume that there will be a leadership buy-in. That means everybody nods their head, saying that we want to go ahead with the MLOps. Okay, we have a robust strategy for data defense versus offense. Okay, that means we understand what's our BI and AI portfolio, and the defense is how strong we are on our foundational elements of data, which is the platform versus governance versus quality, MDM, and everything. The teams are collaborated, teams are set, they are collaborative, they understand each and everyone's responsibility, and then there is also a skill for developing the CI/CD for machine learning, and that does exist. That means if all these factors are checked, we are in the big breakthrough stage. How do we go next to a strategic level, which is more like in transformation level? We are moving from, say, digital transformation to being more smart and transforming the business, is where the AI becomes a strategic arm. We have an enterprise level data platform, and not just for the data retention, but we also have the platform for data consumption. We have a comprehensive MLOps strategy. We have governance and security frameworks implemented both at the data level as well as the ML ecosystem level. That is where we say that, okay, now we are at the strategic level. So this is a good trajectory to go past. It's a journey. It cannot happen in a 3-day process. It takes its own sweet time to jump from one level to another. Towards the end, I have tried to put some references which are good reads, and we often reflect into these documentation to find out where do we stand, to learn some new concepts. In the interest of time, I'll take a pause here and take some Q&A towards the end.
Thank you, Saurabh. There are a bunch of questions. Would you like me to, speak out for you, or you would want to just have a look and see what all questions you can take it up in next 9 minutes?
Okay, sure. So I can see a list of questions. Let me start with the most recent ones. Okay, so the last question that I see, that which tool is the best in the industry for ML operations, from Santosh Jaiswal. So as I said, so ML ops is a practice. Okay, it's a bunch of practices that we can implement for to build the ML ecosystem. And I've seen there are organizations who are building these, provisioning their homegrown systems for MLOps. Okay, there's no rocket science that we need few offerings from different tools and we need to, build a mess of tools to exercise MLOps. It's a practice. So depending on my scale, if I have 4 to 5 models or say 10 machine learning models, I can better build everything on my own rather than investing a lot and buying a Ferrari for just to run a bicycle. So it's a set of practice. Once we see the scales growing, and as I said again, the cloud service providers, for example, Azure is quite mature on the ML ops. AWS again has a continuous offering on the ML operations. So if and they offer a complete ecosystem of exercising or say putting ML ops into the production. Okay, so my answer is there's no one tool. Of course, there are products available in the market, but then it depends on how do we measure the depth of ML in our organization. If it is growing, of course, by all means, we should go for a specialized tool. The second question from Santosh again is, can you please more light on the model security and in MLOps? Okay, so the model security comprises of two things. One is the data and the model access. Okay, so there are two elements in a machine learning model. One is the data on which it is run, and the second is who accesses the model and in by what means. So the data security is part of data ops. Okay, you can of course and some of the techniques, some of the malicious techniques that I have seen in the ML ops, in say ML model, is poisoning of the training data sets, which will uh, degrade the performance or say degrade your classifiers, and it will directly impact your business. So what data the ML model is getting trained on is very, very important, and we have to secure the training data set. Okay, it has to be cleaned, it has to be validated. The second area where the models security has the chance of getting violated is who accesses this model and with what intention. So if I have the external exposition of these ML endpoints, it's very often that I can go and I can trace back. If my model is not designed that way, I can trace back that on which data set it was trained. For example, I'll give you a very simple scenario. If I have an API which simply detects a model, okay, detects a fruit, and I keep on throwing in the same fruit again and again, again and again, and I get the similar set of accuracy, there are chances that I would be able to trace back that on which training data set it was prepared. If out of 10 such chances, 8 out of 10, if I get to know that there's an apple, and remaining two, if I throw a different fruit, but the prediction is wrong, I know that this model was particularly trained for apples. Okay, so that's the another security breach that can happen with AI solutions. So the model security is both the ways, from the data side and from the consumption side as well. Then there's a question on difference between the data ops and ML ops. Who does what? So data ops is the team which is responsible to provide the data in a right quality format. And if you are working in a data lake sort of a setup, then data operation takes care of bringing in the data from, or say, controlling the data movement from different systems to this centralized environment, and making sure that the data flow within this environment is governed, and it's not building up a data swamp. So data operations also play a critical role on the consumption layers of the data lakes as well, by uh, keeping a check on how this data is getting consumed, and who has the access. So basically the security and access framework and privacy aspects of the data. So if you ask me, it's data operations plus the governance which builds the data ops. MLOps, which was the subject of this session. Now, MLOps is how do you operationalize machine learning models, which is slightly different from DevOps, machine learning ecosystem management. So MLOps will be more concerned about the model management, model monitoring, and model versioning, and model management, that how the model is performing and what are the key metrics, what are, whether the data drift is happening or not, or whether the model is deviating from its specified expected threshold or not. So, and then, how do you retrain the model? How do you select one model which has the best uh, accuracy from the bunch of experiments? So these are the teams who are part of the MLOps, or these are the activities which MLOps teams do usually. Okay, then there's a question from Rangesh, how to train the model if we are in a business not developing data solutions to client, by combining various data categories from third-party providers, the in-house application for mapping data using data warehousing concepts. However, there won't be any standard data that will be flown. So I believe what I can understand quickly is this question is regarding if the model is using the data from disparate sources, and if you are developing these solutions for the clients. Okay, these two things which I can see in this question. Not sure how precise I am, but I would try to answer this question. So if your model is consuming data from different sources, and whether or not we have the control on those systems, but this model is something which we have built, and I would correlate this situation very well with something like a Kaggle, where there are data sets. We are taking those data sets, we are trying to build the model. So I don't see if the data is flowing in from different systems, there should be a challenge in training the model. You can still stage the data at some place, and which is required for this model set, and then you start with your data exercise. You can start with data wrangling. You can feed in the data into your model, and then you can train the model. Question will come when you want to retrain the model. What would be that scenario if you want to retrain this model, and how do you know that there's a change in the model, or some problem, some challenges with the model? So I know that will be a challenge, but if you are developing this model for third party source provider, or say some other clients, then yes, if you have to publish these metrics every now and then, and let them know, give them the complete visibility what level of AI they are using, and if it is aligning, then well and good. But if it doesn't, then you have to go back to the providers again and ask for maybe much more data and quality data to retrain these models again. I hope I have answered this question, but if I have not, feel free to get in touch with me later on and can happy to discuss. Okay. What was batch scoring? Okay. I guess in 1 minute I can say that batch scoring is nothing but scoring of these models which are towards the end, which are on the ML in the EML ecosystem, which are on the production pipeline. Uh, how do you score these models? Which one is doing good? Which one is not doing bad? Not doing good by a level of a threshold that we say.
Saurabh,
Yep.
I'm so sorry to interrupt, but this is already 3:30, and
Yeah.
I'm sure there are so many more questions the audience would want to ask, and they've already asked. So I request that you can reach out to Saurabh over LinkedIn, and probably, or you can send your questions to me, and I'll try to send it to Saurabh, and then we might solve your queries.
Sure.
So thank you so much, Saurabh, for this amazing presentation. And I must say that was a wonderful session. And for all the other audience, I will meet all of you on 6th of August on Bots on Digital Channels. The registration link I'm just sending you over the chat window. And thank you, Saurabh, for your time and efforts. And thank you so much, everyone.
Thanks, Ankita. It was a lovely session. Thank you.
Thank you so much, everyone. Please take care. See you soon.
Bye bye.
Bye.